This question says, using the reaction below, how many moles of potassium oxide can form from each of the following? And we have 4K plus O2 yields 2K2O. So we have 4K, 4K, O2, 2O. We're good to go. It's all balanced. So what we want to do is we want to start with 8 moles of oxygen, and these are all independent of each other. So in this case, we want to convert from moles of oxygen to moles of potassium oxide. So if we start with 8.0 moles of O2 oxygen times. To convert from moles of one thing to moles of another, we always need a balanced chemical equation, and we need the relationship between the two things. In this case, we want to put 1 mole of oxygen on the bottom. So moles of oxygen will cancel out. Also notice that I labeled this as moles of oxygen, and moles of oxygen, not just moles, because this is going to be moles of potassium oxide on the top. In this case, since I'm trying to find how many moles of potassium oxide I can form, I want to put the 2 moles of K2O on the top. Multiply by the top, divide by the bottom, and here, to 2 sig figs, you get 16 moles of K2O. Let's look at the next one. 15 moles of potassium, this one. So in this case, we have 15.0 moles of K, and we want to convert it to moles of potassium oxide. Again, to convert from moles of one thing to moles of another, we're going to use a balanced chemical equation. In this case, we want to put 4 moles of K on the bottom and 2 moles of K2O on the top. Multiply by the top, divide by the bottom. In this case, we have 3 sig figs, so it's 7.50 moles of K2O. The last one's a little bit more challenging. Here we have 36.4 grams of potassium instead of moles of potassium. So we can't convert from grams of this to moles of this directly. But what we can do is convert from grams of this to moles of it, and then to moles of this. So by way of a plan of attack, we want to convert from grams of potassium to moles of potassium, and then just do what we just did before, convert it to moles of K2O. So we have to do it in multiple steps. In this case, we want to do 36.4 grams of potassium. To convert from grams to moles, we need to use the molar mass, which is given on the periodic table. And for potassium, it's 39.10 grams of potassium is 1 mole of potassium. Now we want to do the same thing as before. We want to convert from moles of potassium to moles of potassium oxide using the balanced chemical equation. We want to put the 4 moles of potassium on the bottom, so moles of potassium will cancel out, and we want to put the 2 moles of potassium oxide on the top. Multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, and in this case we get 0.465 moles of K2O. So what you'll notice is this is basically a dimensional analysis problem, which is applied to chemistry. So this is, when we went over all those dimensional analysis problems, here's an application you could use it where you can't just move the decimal point or just multiply the numbers easily. It's much easier to set it up like this in order to find the answer. It's really important to practice with this kind of stuff because it comes up a lot in chemistry courses.